This is for Year 12. This comes out of Heffernan 2020 Exam 2 question number 4. So we have time to complete her workout is normally distributed with a mean of 30 and standard deviation of 2. So T has a mean of 30 and a standard deviation of 2. Find the probability that she takes less than 25 minutes to complete her workout, correct to 4 decimal places. So we have a normal situation here, 30 less than 25 is going to be a normal CDF, negative infinity to 25, 2 and 30, and I'll just do it on my calculator. Interactive distribution continuous, normal CDF, lower is negative, line math to infinity, to upper is 25, 2 is the standard deviation, and 30 is the mean, and that gives me that to 10 to the negative 3, so move the decimal place 3 spots, 0.12, then 62096, to 4 decimal places, 0.0062. Okay, part 2, find the probability that she takes less than 25, given that she takes less than 30. Correct to 4 decimal places. So we have a conditional. So I've got the probability that t is less than 25 intersect t is less than 30, or the probability that t is less than 30. That's going to be the probability of t being less than 25 and the probability of t being less than 30. Now, the overlap of that will be on a number line, less than 25, less than 30, less than 25 is that's the same answer as up here, 0.0062096, and probability of being less than 30 is 0.5. So if I take that answer and divide it by 0.5, I get this answer, which is 0.12419. And I'm doing it to 4 decimal places, so 0.1242. What would it look like if I was doing it all on calculator? I'd have that in the numerator, and in the denominator I want less than 30. And lo and behold, I get the same answer. Okay, part C, she completes 5 workouts each week. Alarm bells tell me I've now moved to a binomial where n is 5, probability that at least 2, less than 2 are completed in less than 25 minutes. I know the probability of being less than 25 minutes is this, because that was the probability of being less than 25 minutes. So 0.0062. So notice this question here picks up the probability from up here and uses it as the p-value for my binomial. Remember, for our binomial, if it's less than 2, that's the same as it being less than or equal to 1. So I'm now doing a binomial CDF. The lower is 0, the upper is 1, n is 5, and 0.0062 is the probability of success. Interactive distribution, discrete this time, but discrete CDF. Lower is 0, upper is 1 because it's going to be less than 2, 5 and 0.0062. Yep. I get an answer of 0.996. 3 nines and a 6 to 4 decimal places. 2 marks. The fact that it's binomial, once the examiner sees that, then they're comfortably giving you the 1 mark. Okay, the second part of this question takes a bit of a turn. She continues to complete 5 workouts each week, so it's still binomial. Her trainer wants to monitor the time to complete a workout, so the probability that she completes one or more or two workouts in less than m minutes is maximised. The W is the probability that she completes one or two or five liquid workouts in less than m minutes. So I don't know what P is. I've got to find P, but I've got to show that less than m, so it's one or two. So the probability that she completes one, so T equals 1, or probability that T equals 2 is equal to that. So T is binomial, it's still 5, but I don't know the probability because that's what I'm trying to work out. So that will be 5, 1, P to the 5, 1 minus P to the 4, plus 5, 2, P to the 4, 1 minus P to the 3, and on my calculator, if I go down, advanced, is my NCR 5, 1, that's 5, so that's 5 P to the 5, 1 minus P to the 4, plus 5, 2 is 10, P to the 4, 1 minus P to the power of 3. Now, I'm looking for this. I'm thinking I'm going to have a common factor of 5p. So if I have 5p, take a 5 and a p out, that is p to the 4. It's only worth 2 marks. I reckon I got most of it. I'm just going to fudge the rest of this because I'm going to have enough that's going to give it to me. Plus 1 minus p cubed. Done. Okay, find the maximum value of W. Didn't even need to do this because I'm now working with this because I'm told what W is. So it's equal to 5x bracket 1 minus x to the power of 3 and then 1 plus x. And I want to know the maximum value of W. So interactive calculation Fmax. And I'm told that the maximum value is infinity when that's, but I know that P can only go from 0 to 1, can't it? So if I come back up here and put, so grab this again. Calculation Fmax, my lowest has to be 0 and my highest has to be 1 because x is P. And I get, am I doing it to decimal places? I am doing it to decimal places. So the maximum value is 0.6694 when P equals so P equals 0.289897. So 4 decimal places is P equals 0.2899 and W equals 0.4. 6695 and WF max is the method. Find the value of m for which the maximum value occurs, correct to 2 decimal places. So m is the number of minutes that she does her training, and the probability of being less than m is p. So the probability that t is less than m equals p, 0.2899, remembering that t is a normal distribution. So for it to be 2899, m's got to be some value less than 30. So I'm going to use the inverse normal to find the value of m. So what I've got is 30, 0.2899 m. So I'm going to inverse normal, left, 0.2899 is a probability, and 2 and 30, and that should give me my value of m. Left 0.2899, 2 and 30. 28.8926, and I'm doing it to 2 decimal places. M equals 28.89 is the value of m. And that's question number 4.